Hello guys, in our today's video we are going to look at science paper 2 2022, specifically section A only. So the first one, which is A1, reads, which of the following best describes why a factory manufacturing pesticide should be located far away from human settlement? So we have pesticide dash. So A is saying are poisonous, B contaminate the environment, C destroy buildings, D we have may kill animals. So all these they are falling under contaminate the environment. So the best answer here it is B, which is contaminate the environment. So we have A2, which is saying which of the following is not a basic unit of matter? So we have three basic units of matter. So the first one is an atom, then followed by an ion, then the last one is a molecule. Now this question is saying which of the following is not a basic unit of matter? So the answer here is going to be B, which is an electron or electron. Then as A3, which of the following shows the best order of obtaining salt from a mixture of sand and salt? So here we have two things, this salt and this sand, or sand and salt. So the first thing, we need to dissolve sand and salt in water. After dissolving those sand and salt in water, we need to filter the sand out. Now remember, we have sand and water, and then when you dissolve we have sand and salt. When you dissolve it in water, we are going to find that when we filter the sand, water and salt is going to remain as a solution. So then the next one, we are going to evaporate some water, and then at the end the crystals they are going to be formed. Okay, so the correct answer here it is A. Then A4, the best method of separating iron fillings from copper powder. So we know that iron fillings can be attracted to a magnet. So here we are going to say D, which is magnetism. Then A5, in which of the following are the greatest intermolecular forces? So as for group 7, as you go down the group, the intermolecular forces increases. So we have bromine, which is A, B we have chlorine, C we have fluorine, and then D we have iodine. So the correct answer here it is iodine. Okay, the last one, which is on this part here, which is AC. The following dot and cross diagram represents a compound. So as you can see on the first structure here, this compound has lost 2 electrons, and then the next one has gained 2 electrons. So I'm going to say the first one here it is a metal. Now how am I going to identify that this one is this one? So let me count the electrons. So here, if you count the number of electrons that it has 10. Now it has lost 2 electrons, which means here we are having 12 electrons. So magnesium has 12 electrons. Then here we have a compound which has gained 2 electrons. So this compound here is found in group 6. So now as you can see, here we are having A, which is magnesium chloride. Now chlorine is found in group 7. And then we have B, which is magnesium oxide. Oxygen is found in group 6. So the answer here it is B. Then C is saying sodium chloride. Chlorine is found in group 7, and sodium is found in group 1, which means here we are supposed to have 1. Now this one here is having 2 positive. Okay, then the last one, sodium oxide. Of course, this one here it is oxide. Now as for this one, the first compound here it is magnesium. So I'm going to say the answer here it is B, which is magnesium oxide. So let's move on to the next one. So the next one is saying which of the following liquids when added to a strongly acidic solution in the correct amounts could produce a solution with pH of 7. So A, we have distilled water. So distilled water is not a base because here they are talking about the neutralization reaction. As for neutralization reaction, when a base reacts with an acid, water and salt is produced only. So I'm going to say B, which is ethanoic acid. They are talking about the reaction between an acid and a base. So B is not the answer also. C, lime water. Lime water is not the answer also. Then D, we have potassium hydroxide. This potassium hydroxide is a base, a strong base. So when this one is reacted with any acidic solution, we are going to find that salt and water is going to be produced. Okay, so the answer here is D. Then A9, let me say A8. What is the identity test of the gas produced when an acid reacts with a carbonate? So when an acid reacts with a carbonate, a salt, water and carbon dioxide is produced. Now to test the presence of carbon dioxide, since we know that carbon dioxide is a gas, so we are going to introduce the lime water. So now what usually happens here is that lime water turns nuclear, okay, or cloudy. So we are going to find that if we bubble carbon dioxide in lime water, the lime water is going to change nuclear. Okay, so the answer here is D, which is saying turns lime water nuclear. Then we have A9. A9 is saying 25 centimeters cube of 1.0 mole per decimeter cube as let me say sodium hydroxide solution are measured into a 100 centimeters cube volumic flask and water added to make the solution up to 100 centimeters cube mark. So the concentration of sodium hydroxide in this solution is, so for us to calculate this one, let's collect data. So the first one here we have the volume, which is 25 centimeters cube, and also the concentration, or we can say molarity, which is 1.0 mole per decimeter. Okay, so here I'm going to say apart from this one, we also have 100, which is the volume, 100 centimeters cube. Now how it is here, for us to calculate this one here, we are going to use the law of dilution. So the law of dilution states that the number of moles, even if you dilute the solution, the number of moles remains constant. So here I'm going to say M1, which is the molarity or concentration, multiplied by V1, which is the volume, is equal to molarity 2 multiplied by V2. Okay, so for us to answer this one here, we have been given the molarity for the first one, which is 1.0. So I'm going to say 1.0 mole per decimeter cube. Okay, multiplied by, now here as you can see here, the volume here is in centimeters cube. So there is a need to convert this one into decimeter cube. So how it is here is like this. 1 decimeter cube is equal to 1000 centimeters cube. So let's convert 25 centimeters cube. So here we're going to say 25 centimeters cube divided by 1000. Okay, so once we divide, we are going to find that our answer for volume is going to be 0.025 decimeters cube. So here we can say 1.0 mole per decimeter cube multiplied by 0.025 decimeter cube is equal to molarity number 2 we don't have, multiplied by volume. Also we need to convert this one, which is 100 centimeters cube. So 100 centimeters cube divided by 1000 centimeters cube, we are going to get 0.1 decimeter cube. Then from there we are looking for molarity number 2, so we are going to say divide by 0.1. Even here is divided by 0.1. So here I'm going to say 1 multiplied by 0.025 decimeter cube. The answer is going to be 0.025 decimeter cube divided by 0.1. We are going to get 0.25 decimeter. Let me say more decimeter or more per decimeter cube. So our answer here is going to be A. Okay, so A10 is saying what mass of sodium carbonate is required to make a 250 centimeters cube solution whose concentration is 0.3 molarity. So I'm going to say concentration is also known as molarity. So molarity is equal to number of moles over volume. Okay, so volume here we need to convert it into decimeters cube. So like there I was saying, 1 decimeters cube is equal to 1000 centimeters cube. So here let's convert 250 centimeters cube into decimeters. So 250 divided by 1000, we are going to get 0.0.25 decimeter cube. So here I'm going to say molarity, which is 0.3 molarity, is equal to the number of moles. The number of moles there we don't have, so let's find this. Let's first find the number of moles. Then the volume we have, which is 0.25 decimeters cube. So we are looking for the number of moles. So here we need to cross multiply. So the number of moles here is going to be 0.25 multiplied by 0.2. Let me say multiplied by 0.3. Then the answer for the number of moles is going to be 0.075 moles. Okay. Now since here we are looking for the mass, we are going to say number of moles is equal to mass over Mr, which is the molar mass. Okay. So for us to find the molar mass, we are going to say we have sodium carbonate. So the first thing here, let's find first the molarity or the Mr of sodium carbonate. So the first thing I'm going to say, we have two atoms of sodium. So I'm going to say 2 multiplied by the mass number, which is 23, plus we have 1 atom of carbon. So 1 multiplied by 12 plus 3 multiplied by, so here we have 3 atoms of oxygen. So 3 multiplied by the mass number of oxygen, which is 16. So when we multiply here, we are going to get 106 grams per mole. That is the Mr or the molar mass. So here I'm going to say the number of moles, which is 0.075 moles, is equal to the mass, that which we don't know, over 106 grams per mole. So here I'm going to cross multiply. Then my mass here is going to be 7.95 grams. That's the mass of sodium carbonate, which is B, the answer. Okay. The last one on this part here, A11. An experiment was carried out as shown in the following diagrams. So we have in experiment 1. So the height there, it is 8, let me say the volume there, it is 80 centimeters cube. Even on experiment number 2, it is 80 centimeters cube. So we are having water. Then they have added sodium, the piece in experiment 2. So we can say 5 grams pieces of sodium metal in experiment 2 they have added. Now as you can see here, in experiment 2 we are having small pieces of sodium. Okay. Then in experiment 1 we have large pieces or lump of sodium metal. So the question is saying, where was the reaction faster? So now, as you can see in experiment 2 we are having small pieces of sodium metal, which means there we are going to have a large surface area for the reaction compared to experiment number 1. So here I'm going to say in experiment number 2 the reaction was very faster. So my answer here is going to be B. Okay. So let's move on to the next one, which is A12. A12 is saying, which of the following best explains why hydrogen is not placed in any group on the periodic table? So here I'm going to say C, because properties of both are group 1 and group 7 elements. So hydrogen has an electron number of 1, so it can gain 1 electron from group 1 for it to become stable, and also it can give 1 electron to group 7 so that group 7 can be stable. So as for A13, is saying the atomic symbols of elements W and Z are as follows. So we have the mass number for W, which is 39, and then the electron number, which is 19, and the element Z, which has the mass number of 35.5, then the electron number, which is 17. So here I'm going to say, as for Z is going to be chlorine, and then W is going to be potassium. So when potassium reacts with chlorine, a salt is going to be produced, which is potassium chloride. Then the question is saying the compound, the base units of the compound formed by W and Z are, so A is saying atoms, B is saying ions, C is saying molecules, and then D is saying radicals. So the correct answer here, it is B, which is ions, because these two, they are going to exchange their ions. So as for W, it is a metal, so once it gives one electron to the chlorine, we are going to find that W is going to be positively charged and then Z is going to be negatively charged. So that's ionization. So the correct answer here it is B. Okay. So the next one is saying, which is 14, element X is less dense than water and reacts fast with cold water, liberating a gas. Which details are correct about element X? So according to the reactivity series, on this metal here that we have been given, sodium is more reactive. Okay, sodium is more reactive. So when sodium reacts with cold water, hydrogen gas is going to be produced and then the solution is going to be alkali. Now sodium is found in group, let me say in period 3. So the answer here it is going to be D, which is sodium, the name of the element which is sodium, then the period which is 3, type of solution alkaline, then the gas which is hydrogen. So it is D. Then A15 is saying the following diagram shows the ionic lattice of a substance. So these are the charges. So we have 2 to the power negative. So which means this one here it is a non-metal and it can gain 2 electrons. Then this one here it is a metal which is positive. So here I'm going to say so this one here is the question is saying what is the substance likely to be? So as for magnesium chloride, this magnesium has the valence of 2 and it can lose 2 electrons for it to become a positive. So we can say it is 2 to the power positive. Now this one here it is saying 2 to the power negative, which means this one is not magnesium. So magnesium out, which is A, even B, which is magnesium out. Then here we have sodium. Of course, sodium is a metal, so it can lose 1 electron for it to become stable. So we can say sodium, of course. What about chlorine? Chlorine, it can gain only 1 electron for it to become stable. Now, as you can see here, they are saying 2 to the power negative. So which means this element can only gain 2 electrons. So even sodium chloride out. So the D is saying sodium oxide. So oxygen can gain 2 electrons. Okay, and then sodium can give 1 electron. Now, according to the valences, they are going to exchange since oxygen has a valence of 2 and then sodium has a valence of 1. So we are going to say it is sodium oxide. Okay, so the answer is D. So let's move on to the next one. So the next one is saying